Hi there, I'm Wes with Process Technology. What I'm going to do today is show how a calibration is done on an MSA gas monitor. So what I've got here, I'll just give you a quick layout of what's going on here. This is a MSA Ultima X monitor, transmitter head here with an integrally mounted infrared sensor. This is for a combustible gas, methane. But the same principles apply across the board as far as calibrating MSA sensors on monitors. So that's what I've got here. I've got my calibration gases. This is oxygen and nitrogen, so my zero air. This is methane, since I'm going to be calibrating a methane sensor. And then for both bottles of gas, I've got a 1.5 liter per minute regulator to regulate the gas that for the calibration, and the tubing for the regulator onto the calibration cap here. And then also important to the equation is the controller. There's also another handheld unit available called the calibrator that you may be aware of, and it's the 3 push button one, and it's about the size of this panel right here. So that may be the one that you have in your calibration kit. This has a lot more functionality to it. It's a little more expensive, but there's a lot of things that you can do with this. Then over here, where this is an infrared style sensor common to CO2, propane gases, and methane, these are more the electrochemical or catalytic bead style. So instead of having this attached to either the remote housing or directly onto the transmitter here, you would have this mounted on, and then your sensor screws into this housing. So this is one of these sensors, either electrochemical or catalytic bead, that's just threaded into this housing here, but again would either connect to a remote housing from this or directly onto the transmitter, depending on the nature of the gas that you're detecting. So what I want to do today is show how to do a calibration on a gas monitor, and I'm going to show you how to do both an initial calibration and a standard calibration. Right now this monitor is showing 9% LEL, so there's something wrong with the sensor. We're going to do an initial calibration, pretending like it's a brand new sensor just being put into service. We'll do an initial calibration, then I'll repeat it, just going through a standard calibration. So for an initial calibration on the MSA controller, I press enter to turn it on. It'll show the current version on there and then say ready. So what I'm going to do for an initial calibration is press and hold the span button. And that will say do initial iCal. Might be a little tough to see. I'm going to hold it over the monitor and press 1. And that puts this into a calibration mode. This will give you 30 seconds to get your gas hooked up and get it flowing. The gas does not need to flow during the 30 seconds unless you've got a sensor that's remote mounted a considerable distance away, 50 feet, 100 feet. You need that gas to be pushing through. So you're going to do your zero gas first. Oh, somebody had that cranked open. So, zero gas. Just let that flow. Usually takes about 30 seconds, 45 seconds, somewhere in between there. And there's on the display, it says apply zero gas. So it does give you a visual indication of what you need to be doing at the time. So we'll run through this process. It shows that it's an initial calibration. It says iCal on there. An initial calibration is typically performed when you put a brand new sensor into service, or you've got a sensor that's in some kind of troubled fault that nothing else will clear out. So now it's saying apply span gas, and it gives me another 30 seconds to take the zero gas off and rig up the span gas. Got about 12 seconds. And again, the gas doesn't need to be flowing during the countdown. I usually let it start flowing in about 5 seconds or so if I'm right up next to the sensor. So you can see it's got the red LED displayed right now showing that it's in a calibration mode. Anytime you get an alarm fault or any kind of fault condition, or if you're in a calibration mode, you'll have a red LED on there. When things are normal, it'll shift back to green. Again, this is about 30 seconds or so of letting the span gas flow into the monitor. We should be finishing up here in just a little bit. It says end, so I can cut the flow off there. Right now it's saying 50%. I've got a normal indication, 50% LEL. That's just because this is a 50% gas. It's dropping down. If I blow that out a bit, you can hopefully see that green LED. You've got about 2 minutes after a calibration before gas exposure will trip an alarm. And it's dropped down to 0. So I'm hoping that you can see that. So we're back at 0. Everything's good with the sensor. Green light, normal status, everything's good, reading 0%. So that's an initial calibration. I'd like to show you a standard calibration too. What an initial calibration does is it sends all of the information that's in the sensor up into the transmitter. So that's why it's important when you first put a sensor into service to do an initial calibration. Standard calibration. So for standard calibration, what I'm going to do, again, on the controller, you press enter. It'll turn on. Takes a few seconds and then it's ready. So there's a button on here that says cal. And I'm going to hit cal, but I do need to be holding it over the monitor. Now it says cal, apply 0 gas, 30-second countdown again, and crack the gas and let it flow. For a minute there it showed 1% LEL, but that was because there was some methane gas in here that was being pushed into the sensor. So it's back down to 0. With these IR heads, you can also technically you can get away with just doing 0, but I think it's a good idea to go through the full 0 and span calibration, just to make sure that, it's definitely picking up reading. So it says end, so we'll take off our 0 gas. Span gas back on, and again this is for methane. Regulator shows how much gas you've still got in the cylinder. And we're at about 10 seconds, 9, 8, 7, 6, 5. So we'll start letting that flow. It's climbing up to 49% LEL. should be finished up in just a few seconds here. And end. Cut the flow off there. That off. That off. We're good to go. It reads 50% LEL. Let's drop it down now. We've got the green light. Percentage reading. Again, there's about 2 minutes after a calibration that there can be gas present in this cap and it not set the alarm off. If you've got infrared style heads, one quick note is that it's a good idea to periodically check the lenses. If you get any kind of dust buildup or condensation or a dead spider or anything like that, it interferes with the signal in here. There's an infrared light source that's generated in here. There's a sapphire mirror here, or a mirror here, and I guess it's a sapphire lens in there. Infrared's shot out, bounced off the mirror, and read back inside the housing here. So if you're getting low signal messages on here, or things just don't seem to be jiving here and calibrations aren't fixing things, it's a good idea to check that lens. You can use isopropyl alcohol and a Q-tip to clean that lens off, and that should be good. There's a cleaning mode function that you want to put this in. Otherwise, without isopropyl alcohol, you run the risk of setting off alarms depending on the style of sensor that you're using. So you do want to be careful with that. So looks like we're good to go on the calibration. And that's an initial calibration and a standard calibration procedure. If you have any further questions, feel free to contact me. My name is Wes. My phone number is 801-541-4310. I work for Process Technology. Our web address, and it's a really good resource for further information, is www.process-tech.com. Anything we can do to help, we try to be a total solution provider. Thank you.